Fine. Now we shall discuss about LCM and HCF. When the numbers are given, natural numbers and fractions, LCM and HCF of fractions. So LCM and HCF of numbers and decimals and exponents. There are 4 varieties, you can see that. Okay. And that is the thing. Okay. And as per the lesson plan, anything to be discussed apart from LCM and HCF? Did we miss out anything from that lesson plan?
No, sir.
We can make up like that, because LCM and HCF is the last item of the lesson plan. If anything is not done, we can finish it up that also. Or any topic, if you did not understand, we'll do also that.
LCM, LCM.
Sir, I was not there for that p square minus 1 where p is greater than or equal to.
Okay, we'll do that. Tomorrow we can do. Remind me, tomorrow we'll do that. P square minus 1 greater than or equal to, p is greater than or equal to 5. Okay, right, another thing. A very small topic that is. Tomorrow, whatever the left out, we can do tomorrow. That is, So today we'll do LCM and HCF. Okay. Right, but so far, if I ask, that is, are you able to understand what classes are going on, what went on? So you understand that, right? And now you can see LCM and HCF of. What is mentioned in LCM and HCF of is that today we'll write with number 1 I'll keep, so that I can write more. So higher the thicker, lesser the content can be written on the board. No? This is visible, no? This is, how do you see this is? If you take number 2, what happens? Like that it will come. This is the 2. This is the 1 size. This is 2 size. Both are visible. No? One I will do. So I can write more content. Sometimes overwriting them. Right. LCM and HCF. LCM and HCF. LCM and HCF. What is LCM? What is LCM? Least common multiple. Least common multiple. HCF is what? Highest common factor. See, this one, even highest also can say, even greatest also can be said, that is. Greatest also can be said. It can be said as a greatest common factor, greatest common divisor. Also you can say that. Factor, or you can say even divisor also. Here. It's like that. Both can be said. Okay. That's highest common. This is the thing. And for these things like of numbers, LCM of numbers, next decimals, okay, next fractions and exponents. 1, 2, and 3, and 4. We need to, that's all. Okay, that is. Because if you look at, no question will be asked straight away here. This is not 10th standard exam actually. But they design the question in such a way, we need to go to this only. There is no other go for us. Questions will be framed accordingly. Now, right, now we can see, first you can see that LCM. See, what is this LCM? Least common multiple. And like you can say, this is, we say least common multiple. Let us say multiples. Multiples of 2 is what? 2, 4, 6, 8, and so on. Multiples of 3, 6, 9, 12, and 15, and so on. Multiples of 4, 8, 12, 16, 20, and so on, like that. Multiples is what? Nothing but table. Already we discussed in the previous classes also. Right. Now, we can say the common multiples. See, this is the multiples of 2, multiples of 3, multiples of 4. Common multiple. Common multiple of multiple or multiples of 2, 3, 4. That's it. So common multiples of 2, 3, and 4. Right. What is the multiples of 2? See that multiples of 2 is what? 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. We get multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24. Multiples of 4. 4, 8, 12, 16, 20, 24, and 28, like that. Common multiples among all three. What are the common multiples you can see? And what are common multiples? 2 you cannot see. You can see the larger number. 4 can, 12. 12 you can see, okay, yes, 12. This is the 12, okay. And next one, what is other possibilities you can see? 16 you cannot see here. 18 can be seen, not here. 20 can be seen here, not here, but 20 here. Again, if you take like 22, 24, 26, 24, 12, multiples of 12, 24. See that? 12, multiples of 12. 12, 24, multiples of 12 is a common multiples. Like what are those things? 12, 24, 36, 48, and 60, and so on. Okay. And there are 12, these are the multiples of all three, common multiples of 3. Least common multiple. What is the least common one? 12. 12 is the LCM. 12 is the LCM. Everywhere we need this. Of course, we did not learn in detail in school level. Okay. So the 12 is the least multiple. Right. Highest you cannot say. Oh, it goes on like that. Least can be known, but highest cannot be defined here. Right. Now, and LCM what is now? Now 2, 4, LCM of 2, 3, 4 or 2, 3, 4. We put like this. This is the method. Okay. Right. And see now we can say 2 and 4 can be common multiples of 2. No? 2 ones are, you can retain 3, 2 2s are. Again finish, it will not go. 1, any number you can take 1, that's all. 2 into 3 into 2. So 2 into 3 into 2. So this is 12. It's like that. 12. So this is the one thing. Now, You can see LCM of 3, 5 and 7. What's LCM of 3, 5, 7? So no number is a multiples of another number. It's all three are primes to each others. Then you can straight away multiply. 3 into 5 into 7. 3 into 5 into 7 is what? 105. So 105 can be divisible by 3. 105 is it means 105 is a multiples of 3. It is a multiples of 5. It is a multiples of 7. Because 105 is a product of 3 numbers. When the product of 3 numbers, the resultant number is a multiples of given numbers. Okay. So when the product of 3 numbers, the resultant number is a multiples of those numbers, given numbers. That language we need to know here. The questions are framed like that. Okay. See, when you can see like a product of such numbers, because CSAT pattern this all. Product of such number always multiples of given numbers or divisible by given numbers like that. Such numbers and also the given numbers is like that. That is a property, that statement. You can write this statement and keep it. Put a rectangular box and write. It's like a property. We need these things. It means the aspirants do not know that to LCM. No, that is the product. The properties of that is required. Okay, it's like that. Now very clear, no? Language you need to, do you understand the terminology is being used? See, that's what is required. Okay, such, we don't know, some such numbers. Then as a given numbers, related with the such and given. Okay, right. And see, now we can say now 3, 5, we are speaking about 3, 5, 7. So when LCM 3 into 5, we don't know the result. Let's say, even it is like that what? 105. And see that 105 is divisible by 3. What is the quotient? What is a quotient? 35. So how did you get 35? Very funny question, no, I am asking. So how did you get 35? So logic, still you have to find the logic that you have to develop the CSAT brains. I'll tell you one thing that is, because you can see, and 3 into 5 into 7 is equals to, so 3 into x. 3 into x. Well, 3 and 3 gets cancelled. What is the x value? Is 5 into 7. Okay. So that you need to develop that logic, that is. It means in the sense what? 3 into 5 into 7 by 3. Correct? This is traditional method, we do that. Gets cancelled, what is remainder? 5 into 7 is the remainder, 5 into 7. This is the equation. This is the traditional method. When I say, whenever you can see the equation, like equality sign is there, no? Numerator, see, left versus right, you can cancel. No, we have seen that is here. That is what is required. Even ratios also. Whenever you see the ratios also, it gets cancelled. Left versus right. Left hand side versus right hand side. So that is the thing. And same way you can take 3 into 5 into 7 is equals to like 5 into x. What would be the result? 5 and 5 gets cancelled here. and see that what is the x value? X equals to 3 into 7, 21. Okay. Sometimes we may not multiply the number so easily unless we have a calculator. So we can put like this, product of numbers. So that is something. Even if you take like that 3 into 5 into 7 equals 3 into 7 into x. 7x. 3 gets cancelled here and 7 and 7 gets cancelled. Well, x value is what? 5. X1. This is what we need, this step. This step we need here for exam point of view like that. You know the LCM. I don't say you don't know. You know that well. Otherwise you cannot pass the 10th standard exam. See, that is a thing. Now we can see. Now we can see that LCM of any given numbers. For example, I will give some more techniques you can relate. So find the LCM of. You can take LCM of like 2, 4, okay, and 6, 8. What is the LCM of 2, 4, 6, 8? Is what? LCM of 2, 4, 6, 8. 8. How it is 8? See that. 24. Yes, 24 is the LCM. I'll tell you. Now we can see LCM always can be a larger number of given numbers. LCM is always the largest number of the given numbers. What are the given numbers? 2, 4, 6, 8. What is the largest number? 8. Check that. Whether 8 is divisible by 2? Yes. 8 is the divisible by 4? Yes. 8 is divisible by 6? No. Then you have to find for 6 and 8. 6 and 8. It means what? 2 3s are 2 4s are 2 2 no over 2 6, so 24 it will come. Or we can see now 8, largest number is what? 8. So 8 cannot be divided, 8 is not the multiples of 6. Then you multiples of 8 you have to see. Multiples of 8. What is the next multiples of 8? 16. 16 is divisible by 6. For 2 and 4 you need not to check. Already 8 is a multiples of 2 and 4. And 6 multiples of 8 is also multiples of 2 and 4. Only thing is you have to check for only 6. And multiples of 8, 16. 16 is not the multiples of 6. Next, 8 into 3, 24. 24 is the multiples of 6. 24 is the LCM. 24 is the LCM like that. That the largest number you have to see that. This will help you in especially CSAT exam. Statement 1 required, statement 2 required. There it will look at. Next you can see like another examples. See, and 3, 5, like 15, and like you can take 25. What is the LCM of these 4 numbers? 3, 5, 15 and 25. Now we can see 25 is the multiples of 5. Okay. 50 is not the multiples of 15. 75. If you go to 75 is the multiples of 15. 5. 50, 25 is already multiples of 5. Multiples of any such number is goes. 75, yes, 75 is the LCM. 75 is the LCM. The largest number you have to check. Largest number you have to check.
So largest number should be divisible by remaining 2 numbers also.
Any given numbers.
Yeah, there is 16.
You have to see that if you take here, if you take 25 as the largest number, is 25 multiples of 15? No. 25 multiples of 5? Yes. And multiples of 25 definitely is multiples of 5. The other numbers you have to check that.
Sorry, if in place of 15, 16 is there means, then we should go to next.
Okay, you will just tell me, I will write here.
3, 5, 16, 25.
16, 25. 25 again is a multiples of 25, that's fine. 25 is not the multiples of 3. 25 is not the multiples of 16. Again, you have to go to the next. 50. 50 is also not multiples of 16. 75, no. 100, no. 125, no. 150, no. So next 175, no. 200, check that. It's not possible. It goes very bigger number now. You have to do now. Now you have to do the traditional method, that is, goes well. So now 5 we need not to take. 3, 16, 25. 5 we need not to take 5. Okay. And we can take, now we can see this is the even number, na? Right. What happens now? We can see here, no such numbers will multiply. Straight away we have to multiply. 400 plus into 3, 1200 it goes. It goes to 1200. Already it will come to know here. So 1200. It's like that. But one basic idea we should have, because nowadays what happens now, for the last 3-4 years, statements are being increased in the question paper. They started with the 2 questions are statement basis. Now they came to 4, they come to 5, 6, like that, happening that. It means original concept must be known to the aspirant. That is what they expect, like that. Right. When I give the question papers, I cannot come back and tell that is. So we are bound to waste many number of classes like that. Okay, this is the thing. And if you take like LCM of 3, 12, 96, okay, and 87, what else and what? Looks quite bigger number.
Sir, everything is divisible.
By?
15, no?
Yes. Now you can see here 3, 12. Okay, 12 is a multiples of 3. Now, multiples of 3 means you can sum up the digits. Already I told in the previous class divisibility rule. 9 plus 6, 15. 15 is a multiples of 3. Yes. 87, 8 plus 7, 15. 15 is a multiples of 3. It means all these numbers are multiples of 3. Then what, which is highest number here? 96 can be taken. LCM. This is the LCM. This is the LCM. And not that we are finding LCM here, but we have to, you need to understand the concepts of structure. Concept of structure. So, but 96 is not divisible by 87.
Yes, sir.
Isn't it?
First case,
Yes, yes.
2, 4, 6, 8.
96 cannot be divisible by 87. 96 is divisible by 12, but not by 87. So 96, 87 you have to see. Multiples of 96 and 87 you have to take. You need not to do for the 3 and 12, because 96 is a multiples of 12. 96 is a multiples of 3. You can take. Both numbers are multiples of 3, isn't it? 3, 2, 3 to 6, 8. No? Right. Now both are even numbers. 2 16, 2 14. Again you can take 2 8, 2 7. Over. And 3 into 2, 6, 6 into 2, 12. 12 into 8, 96. 96 into 7. 96 into 7. Whatever it comes. 672 you can take. 672 you can take. Okay, yes. Next, this is the how it can be derived, LCM. See, it means what? LCM means what? The largest number of the given numbers or multiples of the largest number. What is the definition? Can we say that? What is LCM? Largest number of the given numbers. Whichever the numbers are asked, only we find LCM. Not, you cannot say, simply cannot say largest number. Largest number may be 1 million also. Largest number of the given numbers or multiples of that largest number of the given numbers. So that is the definition. Okay, right. And now we can see, right, that is the thing. Now you can see here, here what is the largest number? 96 or multiples of 96. LCM is what? Largest number is 96 or multiples of 96. That is the thing. Okay. Yes. Next. Now we can see for example, say find the LCM of 3, 0.3, 0.03. Then how do you do that? 3, 0.3 and 0.03. See, when the decimals are given, that should be LCM and SF is always for natural number. There should be a natural number. Without natural number, you cannot do that. And these decimals also must be converted into the natural numbers. The decimals also must be converted to the natural numbers, because these are not the counting numbers. Okay. Now what will happen? How many? What are the maximum decimals can be seen among the given numbers? 2 decimals. This is the 2 decimal. Here is what? 1 decimal. Here no decimal. But what is the maximum decimals? 2. So you have to convert 3.00. Now uniformity, you can see that. And here what? 0.30 and 0.00. Sorry.
0.0.
Yes.
0.37.
0.03. That's right. Now you ignore the decimal, you just write the numbers. 300, 30 and 3. What is the biggest number? 300. 300 is a multiples of 30? Yes. 300 is a multiples of 3? Yes. Then LCM is 300. But therefore, the final answer, how many decimals we have adjusted this here? 2 decimals. So 3.00, then 3 is the LCM. 3 is the LCM. That is the thing. Which is the greatest number here? 3 is the greatest number. When a decimal comes no less than 1, 0.03 means less than 1. Left of the decimal is a whole number, right of the decimal is less than 1. And LCM of 0.2 and 0.05 and 7. What is the LCM of these 3 numbers? What is the LCM of these 3 numbers? So ignore the decimal, convert it into natural numbers. It means what? 2, 0.20, 0.05, 7.00, then 700, 5. This is 20, isn't it? 700 is the multiples of 5. When the last digit is 0 or 5, it's a multiples of 5. Multiples of 20 also. When 100 is a multiples of 20, multiples of 100 is also divisible by 20. What is the LCM then? LCM is what? 700.
Not a multiple of 20, sir.
Huh?
20.
Huh.
Sorry, sir.
Yes. Okay. So LCM is 700. But how many decimals we have adjusted here? 7.00. Then it is 7. It's like that. It's like that. It hardly takes 1.5 seconds. Huh? Right. Next. Now this is the decimals. Now is done, and LCM of fractions. Now let us see the fractions. 1/4, 1/2, 3/4. Because this is well known numbers, fractions for us. These three are well known fractions. What is the LCM of fractions? It means now what we have to do? Decimal. If you convert decimal, but okay, you convert decimal, what will happen? 0.25, 0.5, 0.75. Correct? Because well known numbers. Now we can see what happens near two decimals, just like that. Put 25, 50, 75. 75, 50, what? 75 is a multiple 25, but not for 50. 100, 100 can be taken. 75, multiples of 75, sorry. Multiples of 75, 150. 150. Yeah. So 150. Next step is what? 1.50. And next step is 1.5. This is the thing. This is the thing. This is.
So without converting to decimal?
Yes, that's a question. Now we'll do that. Okay. Because this is well-known numbers, fine, we can do. If it's unknown numbers, sometimes decimals, converting decimal consume more time. But those type of questions will not be asked because there is a concept here. Where LCM of fractions is equals to LCM of numerators by HCF of denominators. LCM of numerators by HCF of denominators. See this you put in box. For upper part you can take the LCM, so lower part you can take HCF. See, same thing, whatever we have been learning for several classes, it is well interconnected, interrelated. Now what is the LCM of 1, 1 and 3? 3. Okay. HCF of 4, 2, 4. 2. Now, so 1.5. So the 1.5. Now, yes. Now find LCM of 2/3, okay, 4/3 and 5/7. Now, what is the LCM of these three fractions? Write formula and do it. Okay, write formula and do it. First write the formula. LCM of fractions you write, otherwise you will forget. LCM of fractions is equals to, write the LCM of numerators. LCM of numerators by HCF of denominators. Right. Write formula, then solve it. keep writing because these are very odd expressions. LCM of fractions. LCM of fractions is what? LCM of 2, 4 and 5 by HCF of 3, 3, 7. Like 5 means 10, 15, 20. LCM means what? 20 by HCF of 3, 3, 7, 1. It means it is only 20. So LCM of these fractions is what? 20. Because whenever the denominator 1 is there, we need not to take the value of it also. Okay? It's like that. Now, so LCM of even so 0.2 and 0.3 and 0.4. So you can convert into the fractions and do it also. These fractions, what happens now? We write 2 by 10, 3 by 10, 4 by 10. Okay, it's like that. You can cross check both. So what LCM of numerators is what? LCM of 2, 3 and 4 by HCF of 10, 10, 10. So what happened? 2, 3, 4 means 8 is a 12, isn't it? LCM is 12 and by this is 10. It means 12 by 10, or you can take 1.2. It's like that. It's like that. Even if you do directly, what will happen for this method? There is only one decimal you can take. So 2, 3, 4. Even 2 and 4, 4, 4 and 3 is 12. Because decimals we have adjusted 1.2. See that. Fraction. We are very clear in that. Okay. See, this is of LCM of numbers, so decimals and fractions. Now LCM of exponents. LCM of exponents. LCM of exponents. Two cube into 5 to the power of 2 into 7 and like 2 to the power of 7 into 5 into 7 to the power of 3 into 11. So what is the LCM of these two? What did we learn here? LCM always is the largest number of the given numbers or multiples of the largest number, right? These two common, which is the largest number? If you go 2 cube and 2 to the power of 7 is, which is the largest number? 7. 2 to the power of 7. 2 to the power of 7 can be divisible by 2 to the power of 3. Okay, yes. Then come 5 square and 5. Which is the largest number?
5 square.
5 square into 5 square. If you see, look, 7 cube. Here 11 cannot be seen in the first equation. 11 you have to take because there should be the multiples of such numbers. This is the LCM. This is LCM. Because no 11 cannot be seen here, but 11 is we need here. 11 is there.
If they are not given two numbers, sir?
Huh? No, the question cannot be. That itself is the LCM. Because see, it is not only one equation, that itself is the LCM.
Okay.
That's all. See, for example, if we take 2, 5, 7, what will happen? That itself is the LCM.
Again, we should not do 2 to the power 3, 8, 25 into 7.
Not necessary. So big questions will not be asked. That is time consuming process. No one wants to check that. And see, LCM of now find the LCM of these three equations. This is one expression, second expression, third expression. Least common multiples means that number should be multiples of given numbers. Naturally, that number will be much bigger than the given numbers. First we can take, now we can take 7 cube, 7 to the power of 5. 7 to the power of 5 we can take. Right. Next if we take 11, 7 is done. 11 square, 11 to the power of 1 and 11 to the power of 11, which can be taken 11 to the power of 11 and 13 to the power of 1. And 13 is not here, 13 is not here, only one place it is there, right. And next 17, so into 17, this is the
3 square.
3, oh 3 is not taken, 3 square,
5 square.
5, have you not taken 5? Okay. LCM is what? First you can take 7 to the power of 5 into 11 to the power of 11 into 13 into, now here 3 square into, next we can take 5 square into 17. This is the LCM. This is the LCM. Now we got it. Okay. So multiples of number means that will be much bigger than the given numbers. So this is the LCM of these things. Now now the questions are framed like that. You will see 1 or 2 questions will happen from pertaining to the LCM here. Say for example, there are 3 signal lights on the main road. There are 3 signal lights. All the signal lights starts at 6 a.m. 6 a.m. Okay. This is hours, so minutes, seconds. All the 3 signals starts. Signal 1, signal 2 and signal 3. Signal 1, signal 2, signal 1 changes for every 10 seconds. Signal 2 changes for every 15 seconds and this is 20 seconds. All the 3, if all the 3 signals starts at 6 a.m. again, when do all the 3 signals started together? They ask that. See that together they ask the questions. It means all 3 signals started together 6 a.m. and all the 3 signals, when do they start together?
6.
What is that required for us? Common multiples you need to know. Common multiples you need to know. What is the multiples of 10? Like 10, 20, 30, 40, 50, 60, 70, 80, 90, 90 like that. 15, 15, 30, 45, 60 like that. 20, 20, 40, 60 can take. What is the common multiples? 60. Again is what? LCM. Common multiples is what? LCM, that's all. So if you take 10, 15, 20, 5 2s are, 5 3s are, 5 4s are. Again 2 1s are, 3 2s are. Right. 10, 30, 60. 60 is the LCM. It's like that. For every 60 seconds, all the three signals start together. It means next what will happen? Now it is 6 a.m. For 60 seconds means what? 1 minute. 6 1. Right. Next 6 2. Next 6 3 is and so on. So that is the thing. You will have 1 or 2 questions related from LCM. It's like that. This is the LCM. Questions will come like that. Because LCM comes everywhere. LCM comes everywhere. Even time and work, time and distance, and converting ratios is like LCM. LCM plays a vital role in aptitude. The same question what they can do next time when the question is asked, the same question they may come with the same question, but they put extra information. It means if all the three signals start at 6 a.m., when do how many times all the signals together will start in 1 hour time? In 1 hour time, how many times all the three signals start together? What will be your answer?
Once.
All the three signals. For every 1 minute, all the three signals start together. All the three signals together.
3.
In 1 hour.
60.
60.
The question.
See, all the three signals start at 6 a.m. In 1 hour, how many times all the three signals start together?
60 times.
How it is 60?
LCM.
LCM is okay, 60. But
every minute.
Every minute. But every minute what will happen in 1 hour time? 1 hour means 6 o'clock to 7 o'clock. 6 a.m. to 7 a.m. 6 a.m. also starts 6 1, 6 2, 6 3, 6 4, 6 60. That is 7. 61 times.
1. You should not consider 7.
7 already we have taken. No? 7 already we take 660. 6 1, 6 2, 6 3, 6 4, 6 60 means that is 7.
Sir, I didn't understand.
Okay, sir.
Huh?
I didn't understand.
See, if all the three signals start at 6 a.m., how many times all the three start together in 1 hour time? 1 hour means what? Starts at 6 a.m. up to 7 a.m. How many times? Okay. You take 10 minutes. They are asking for 1 hour. Now you take for 10 minutes. In 10 minutes, how many times they start together? The first starts at what?
6 a.m.
6 a.m. 6 a.m. This is the beginning. Okay. For next one, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6, 6, 7, 6, 8, 6, 9. I am asking for 10 minutes. 10. 11. Why it is 11? First 6, 1, 6, 2, 10 times. So first starting at 6, 1. So 10 plus 1. In 1 hour time, 60 minutes plus 1. So 61 times. See that is. The first option will be, there will be 60. We just go ahead with ticking 6. So to be very careful, that is. Or if you want, try to, you can take for 5 minutes. Oh, 5 minutes, how many times it will come?
6.
So it will be very like thing that is. Okay. Now LCM. And see that 1 by 2, 2 by 3, 3 by 4, which is the largest number? Which is the largest number? So, which is the largest number? Okay, I'll write much simpler also. 1 by 4, 1 by 2, 3 by 4. Now we can say.
1 by 2.
Which is largest number?
3 by 4.
3 by 4. Which is the smallest number?
1 by 4.
What is the difference between 1 by smallest and largest?
0.5.
0.5. Right. How do you say that? Do you prove that? If the fractions are, because these are well known fractions to us. If we write some other fractions, can you say like that? You cannot. First you have to convert these fractions into the natural numbers. How do you convert into the natural numbers?
Decimal.
Multiply and divide.
Decimal. Even if you time decimal is also quite bigger time also, that is.
Multiply and divide.
See, again is a LCM is required. You see the find the LCM of denominators and multiply each fraction with LCM, then that will be converted into the natural numbers. What is the LCM of 4, 2 and 4? What is the LCM of 4, 2, 4? 4 is the LCM. 1 by 4 multiplied by LCM. Because time and work, this property is required. Efficiency of work, it is required. Again see that. Time and distance is required. Even the ratios also is required.
Sir, since the denominator already has 4, why will you multiply with 4, sir?
Because you are converting these fractions into the natural numbers. To convert the fractions into the natural numbers, you have to take the LCM of denominators. That LCM must be multiplied by each fraction.
LCM.
Yes, LCM. And now we can see 1 by 2 into 4.
3 by 4.
3 by 4 into 4. And 4 gets cancelled. 1
2, 3.
and 2. This is okay. And 4 gets cancelled. 3. 1. It means 1 is to 2 is to 3. Which is the largest number? 3. It's like that. Time and work, time and distance, ratio. Chapters, all 3 chapters it is required. Efficiency of work, everywhere it is required. This is.
So this is conversion from
fraction to natural numbers. Converting a fraction to a natural numbers. The LCM of denominator must be multiplied with each fraction. Whole of aptitude, this is required. Whole of aptitude, this is also essential. It plays a vital role.
You have to write 1:2:3 is the last.
Yes, yes.
If only one number means multiply by denominator. Correct.
That's all. When you take LCM with this more than one number, it means there are one part, two parts, three parts. It's like a one part, two parts, three parts. Total number of parts are 6. Total number of parts are 6. Out of first fraction is 1 out of 6. Second one is 1 out of 2 parts of 6, like that. See, you can take total number of parts is how many? 6. It means 1 out of 6, 2 out of 6 and 3 out of 6. Again you can simplify also. 1 by 6, this is 1 by 3, this is 1 by 2. It's like that. So, what is the largest number is what? 6. 6, okay. That is a thing, that is. It goes on like that. So, goes on like that. Yes. Now, I will write one more thing. Find the LCM of, convert the following fractions into natural numbers. Okay. Now 2 by 3, 3 by 5, 5 by 7, 4 by 7, 7 by 11, 1 by 2. Convert the following into the natural numbers. First one what? 70. 70, na?
70, 70. 63. 75.
75.
88, 98, 77.
88, 98,
77.
77. These are the numbers. Now we can count. Because fractions are not the countable numbers. We discussed in the previous class. Isn't it? Decimals are also not counting numbers. That will be part of the rational and irrational numbers. It will come like that. Okay? See that. To count, to say which is bigger than everything, you need to convert into the natural number. Then only it is possible. Right? See, this is the, even because efficiency of work, all things come like this only. Okay? Right. Now we can see. Now let us come to the HCF. HCF is was highest common factor. We discussed about the factors in the previous class. Still once again we discussed like that. I put intentionally like that only. Even if you miss out somewhere, you should be able to cope up with that. Okay, highest common factor. Let us talk about the factor. What is a factor we discussed in the previous class? A divisor which completes divides the number completely is known as a factor. Now let us take 2. So 2, what are the factors for 2? By itself and 1. Isn't it? There are 2 factors for 2 and 1 is the factors for 2. And 3. What are the factors? 3 and 1. 4 itself, 1 and 2. There are 3 factors, isn't it? Okay. For what is highest factor of 2?
2.
Itself. For any number, itself is highest factor.
1, sir. 1.
Okay, so it is like that. What is the terminology we need? That is, what is highest factor of 3?
3.
Itself. Instead of telling 3, you should say itself. And what is highest factor of 4? Itself. And what are the common factors of 2, 3 and 4? 1. That is the thing. You can see 1 here and 1 also here. So like that. That is a common factor. That's a common factor. And what is the common factors of what is the common factors of like 4, 8 and 12? 4. So you can see the 4 will divide 8, 4 also will divide 12. What is the factor? Highest factor is what? 4. That is a common factors. Common factor is what? 4, like that. Highest factor is what? Highest common factor is what? 4. You can take 4, 8, it will come like that. Okay. See, this is the HCF already we discussed. That's why it is easy for us now. Now, same thing. Whatever we did for LCM, HCF is also we know. HCF of numbers. HCF of numbers. HCF of fractions. HCF of fractions. HCF of decimals. HCF of exponents. Like that. Like LCM. LCM is what is the largest number and multiples of the largest number. Factors is what? HCF is what? Least number. Because that has to divide some other number. Okay. Now we can see. Now let us take HCF of numbers. HCF of numbers. Now see, you find HCF of numbers like 2, 3, like 6, 4, 12 and 26, 8, 18, 36. Say that. HCF of 2, 3, 6. HCF of 2, 3 and 6. 1, how? HCF is, because there is a prime number is there. HCF is 1. Because all are even numbers. 2. All are even numbers. All 3 are even numbers. 8, 18, 36. Here also all are even numbers. So 2. It's like that. Otherwise, you will have to find the division method. Okay. Yes. Next. Now. HCF of decimals. 2, 0.3, 0.1. it just convert all the numbers into uniformity. What is a decimals here? Uniform decimal, 1 decimal can be taken, 2.0, 0.3 and 0.1. It means 20, 3, 1. Now one already prime number is there, 3. Less than prime number, 2. When prime number, one prime number is there means okay, finish, only one only. SCF is 1. It's like that. SCF is 1. 0.5, 0.05 and 1.05. You can make it, this is the uniformity. Now what happens now? 55, 105. What is the SCF of these three numbers? 5. Least number is 5. 5 will divide all the numbers. 5 will divide all the numbers. So 5. If 5 will not divide all the numbers, then next lowest you have to go. 4, 3, 2, 1. It will come like that. Okay. See, next you can take SCF of decimals. So 0.5, 0.4 and 0.0 and 2. It's like that. So now we can see 0.50, 0.40, 0.02. It means what? 50, 42. All even numbers now. SCF is what? 2. It's like that. Like same LCM. LCM, what happens now? Largest or multiples of the largest number of the given numbers. SCF is what? Smallest number or lesser than smallest number. That reverse it will come. SCF is what? The number we should divide all the numbers. Naturally, that SCF will be smallest number among the given numbers or less than that also. LCM is what? Greatest number or multiples of that greatest number.
So now if it was 50, 40, 20.
50, 40. Okay, you just tell me, I'll write here.
50, 40,
50.
SCF of decimals. Now tell me.
50, 40, 20.
50, 40, 20.
So that time HCF is 10.
Yes, because 20 smallest number, 20 will divide 40 but not 50. So less than 20, 19, because it's all the even numbers. Again 19 you have to check, 18 you have to check, 17, 16, 15, 15 also will not possible, 14, 12, 13, 11, 10, 10 you can, 10 will divide all, the SCF is 10. It's like that. Or you have to say the division method. Largest number divisible by the next largest.
So in HCF first you have to see the lowest number.
Lowest number.
In LCM you have to see the
Largest number.
Why did they give as a least common factor?
Multiples, least common multiple. Multiples of any number much bigger than the original number. What is the next multiples of 7? 14. It's like that. This is the divisor. They should divide the number. Like 10, 4, 40. Clear. SCF is 10 among the two numbers. Again 10, no 10, 20. 10 definitely you can take. Right. Like now SCF of fractions. HCF fractions. And first we have taken their smallest fraction, 1 by 4, 1 by 2, 3 by 4. What is HCF of? Okay, HCF of fractions. LCM, how did we do that? LCM of numerators. Here also HCF of numerators. Numerators by LCM of
Ulta.
no, not Ulta.
Sir, there it was LCM of
Numerators. There also LCM of numerators.
Sir, there it was LCM of numerator divided by HCF of
Denominator.
Here it is HCF.
HCF of numerator. Yes. Whatever is asked, first one applicable to that numerator. Remaining is for that next. It's like that.
HCF is ulta, sir.
Right. SCF of numerators. So SCF of 1, 1, 3 by LCM of 4, 2, 4. This is the 1, 2.
LCM 4.
LCM 4, right. LCM of 4, 2, 4.
4.
4 is the largest number. It means net answer is what? 0.25 also can be written. If you want, see, if this based on the options given. Otherwise 1 by 4 is the thing that is the thing. Yes.
Sir. LCM of denominator ತಗೊಂಡು ನ್ಯಾಚುರಲ್ ನಂಬರ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ ಸರಿ ಹೋಗಲ್ಲ ಸರ್.
ಯಾವುದು?
ಫ್ರಾಕ್ಷನ್ಸ್ ನ ನ್ಯಾಚುರಲ್ ನಂಬರ್ ಕನ್ವರ್ಟ್ ಮಾಡಿ HCF.
Yes, you can do it. That also you can do
Then
it.
one will come, sir.
See, but we wanted to know the method, this method also. How the questions are framed, we do not.
That method is also right, ma'am.
Which one?
Converting into natural number.
Okay, convert natural numbers. What will happen? 1 by 4, 1 by 2, 3 by 4, right?
Yes, sir.
Okay, what is the LCM of these three?
4.
Denominator 4. So 1 by 4 into 4.
1, 2, 3.
1 by 2 into 4. 3 by 4 into 4. Okay, right. 1.
2.
This is 2. This is 3.
Then HCF will be 1.
SCF is 1.
But differ no, sir.
No?
Answer differ ಆಗುತ್ತಲ್ಲ sir.
Yes. See, here what happens now? This converting to the natural numbers we need to apply. SCF is what? SCF there are only 3 numbers. 1, 2, 3 is there. What is there in that one? 1 by 4 is there. Fractions if you like that. So, and here we are only applying this principle here. 1 by 4, 1 by 2, 3 by 4. No?
Sir, this method is for finding the precise HCF of the fraction.
Previous
that is
one.
for the conversion of to natural numbers.
Yes, that is converting the natural numbers, that is fine. You cannot find LCM or SCF like that. Converting to the natural numbers, to the applicable to that extent.
But if you convert also, it should come also same answer.
We don't know, that's a theorem.
Yes, sir.
They are not
It's
It's
like
universal, no, sir, conversion. Conversion is universal, no, sir.
conversion is universal, yes.
It should be applied for every form, like
It is applicable even in HCF, but you are not finding the HCF in that number, you are just converting the number.
Conversion and
No, he says that should be the universal.
it should be applicable to every.
If it is a universal, like that only. But it's not happening.
Yes, sir. Then conversion is not universal.
Maybe that is the principle has been kept like that.
It is not.
That is only for counting purpose. That's only for counting purpose. Here we can see the 1 by 4 fraction will come. Maybe some applicable theorems are will play that, I think. Huh? Okay, yes, that is a thing. We have to work it out, that also, that why it is like that. But it's not happening.
Yes.
For smallest fractions we have taken. Huh? Maybe some different applications will be there, that is. Right. Only the principal rule is what? See, for example, we have that 1 by 4. HCF is 1 by 4 here. For what? For which numbers? Numbers are like 1 by 4, 1 by 2, 3 by 4. 1 by 4 is divisible by 1 by 4. 1 by 2 is also divisible by 1 by 4. 3 by 4 is also divisible by 1 by 4, or multiples of 1 by 4. Matching rule. If you take the LCM of these three numbers, what will be the LCM? 3 by 4 is multiples of 1 by 4. 3 by 4 is not the multiples of 1 by 2. And 3 by 4, multiples of 3 by 4 is what? 1 and a half. 1 and a half is a multiples of half. So then it will come like that.
1 point.
Yes, yes. That is only the application, this is. That's only till such level it's applicable method, that is. Right. Right, that is now find the HCF of 2 by 3, 3 by 5, 5 by 10. Find the HCF of 2, 3, 5, all three are prime numbers to each other, so one can be taken straight away. 1 by
30.
See, HCF of 2, 3, 5. What is that? Is 1, right? And LCM of 3, 5, 10. 5, 10, 10 was the LCM. 10, 20, 30. Yes. So 1 by 30 is like that. That's the HCF. Okay, fractions. Now HCF of exponents. HCF of exponents. Now we can see what is the first one. Okay, anywhere I'll write like 2 cube, and 3 to the power of 4 and 7 to the power of 2. Another expression you can say 2 to the power of 1 and 3 to the power of 2, 7 to the power of 7, like 5 to the power of 1 and 7 to the power of 5 and 3 to the power of 5.
You have to see the least, sir.
Least, definitely least, because that should divide the some another thing. First you can take the 2, 2 cube, 2, right, 2 is not here. You can take 2, 1. If you take 3, 3 to the power of 4, 3 square, 3 to the power of 5. Least what is what? 3 square,
7.
right? 7 square, 7, 7 to the power of 5. 7 you can take. This is the HCF.
And 5.
5 also is there, na?
Down, sir, third one.
5 is also there. And 5 you can take. 7 to the power of, right? Okay, right, that is it.
Sir, if you convert to natural number means, then we should also divide by that. Then
LCM.
Sir. Like for that one, sir, we take an LCM as 4. So divided by 4. 1 by 4 is the answer.
Which one?
Last, I asked about.
ಇದಾ
ಇನ್ನೊಂದು
So that is a natural.
ಇನ್ನೊಂದು
this one by
Conversion
4.
ಹೇಳಿದ್ನಲ್ಲ ಸರ್, ಕನ್ವರ್ಷನ್ ಅಲ್ಲಿ HCF 1 ಬರುತ್ತಲ್ಲ ಸರ್, ಸೊ ಅಗೇನ್ LCM we got 4 for conversion.
Okay.
Conversion ಮಾಡುವಾಗ 4 ಬಂತಲ್ಲ ಸರ್.
Only one number is there, no? 1 by 4 is there, like that you are telling.
Yes.
Sir,
That-
I will tell sir. 1 by 4, 1 by 2, 3 by 4 is a question, no, sir.
Yes, yes.
Conversion of this number to natural number is a question.
Yes.
The doubt he has is in that. What he is telling is the LCM of 4 to 4 is 4.
4.
When you are converting it to natural number,
Yes.
you will multiply the 4 by divided by 1 by 4, sir.
Okay.
So what he is telling is,
See,
1 is to
this is a 1 by 4 into 4.
Yes, sir.
Okay. For this one, 1 by 2 into
4.
4. For this one,
3 by 4.
3 by 4 into 4.
So you get the answer is 1
We
is
get
to
1, 2, 3.
For we get 1, this is
2.
9.
2.
This is 2.
3.
And this is 3. Yes.
Here HCF is 1.
SCF is 1, like
we have
that.
taken LCM into multiply, no sir.
Oh.
Then we should divide the LCM. Then we will get the
Divide the
correct
LCM
answer.
with everything, every number.
Answer by.
See, LCM for one, if there is a one item, you cannot see the LCM.
No sir. By during conversion, sir, ನಾವೇನ್ ಮಾಡಿದ್ವು ಅದನ್ನ ರಿವರ್ಸ್ ಇಂಜಿನಿಯರಿಂಗ್ ಮಾಡಿದ್ರೆ.
How do you get there? Where did you
Give
get?
more examples so you will get to know.
ಸರ್ ಇವಾಗ
You tell me now. You tell me. We'll work it out. Even I can also see that.
1 by 4, 1 by 2, 3 by 4.
1 by 4, 1 by
Don't
2,
give the same
3
question.
by 4.
3 by 4.
By converting natural number, we get 1, 2, 3.
Yes, 1, 2, this is 3.
Here, now the HCF among this is 1.
This is natural numbers, converted to natural
Now
numbers.
the HCF is 1, no sir.
SCF, if you do like 1, 2, 3,
HCF.
definitely SCF is 1.
I asked it out why the answer is differing. By after conversion.
Correct.
But we have multiplied by 4 now, sir.
Yes.
During conversion, then we should divide by 4.
1 by 4 it will
Yeah,
come.
then the answer will tally.
If you see the fractions like SCF of these fractions, what happens? We get
1 by 4.
1 by 4.
We multiplied, for conversion, multiplied the LCM, that is 4.
Yes,
To natural
LCM.
number. Now
See,
natural number should be converted to
if it is
fractional
the
number.
for same numbers, LCM is what? Like
4.
3 by 4. 3 by
No,
4
sir,
into
it's like
1 and a half. 1 and a half means 3 by 2. LCM is 3 by 2.
Allah sir. For conversion, now we have converted fraction to natural number.
Yes.
By multiplying. Now we should convert natural number to fractional number. So divide by 4.
How that is?
Sir, like that only, no, sir. Sir, how we will convert natural number to?
Sir, you give one more example.
By LCM.
Yes, sir. That only.
LCM is converted numbers now. 1, 2, 3 are the natural numbers for these given fractions.
Then this natural number should be converted to fraction. I am saying.
Fractions, sir. If you want to convert into fractions, sir.
By
See,
LCM.
no, it will not happen.
No, sir. It will like that only.
Sir,
Then
you
the answer will get tally.
Sir, you give one more example. We'll check, sir. You give
This
sir.
one.
Okay, if there is one, there are
2 by
3
3,
numbers.
3 by
1,
5.
2, 3. Now, what is next up? You tell me. I will write here. Whatever you say, I will write here. Then we'll see.
As HCF will be 1 now, sir.
Okay, SCF is 1. Yes. SCF is 1. What's the next step?
There we converted fraction to natural number.
Yes.
Now we also want the answer in fraction. So we should convert natural number to fraction. So we should do reverse. First in conversion we multiply. Now we should divide. Then it will get tally now, sir.
Okay, you tell me now what I should.
Which means here the LCM is 4 among the 1 by 4, 1 by 2, 3 by 4. So we should divide the HCF by LCM, that is 1 by 4. Then the answer will get tally.
No, that's why you tell me. I will write on the board.
Sir, I will write, sir.
Yes. Okay. Right. You write.
See, sir. This 1 by 2, all this is the question.
Fine.
He wanted to convert it into natural number.
Yes.
He got HCF as 1. But when we did that method, sir, when you showed us that
Fraction. If you go by the fractions, it is 1 by 4.
1 by 4.
Yes.
What he is telling is, here, for us to divide to this number, we had to multiply 1 by 4 into 4. And 1 by 2 into 2, 4.
4.
Hello, sir. 3 by 4 into 4.
4.
What he is telling is, instead of we have multiplied here to get this number.
To divide, you say that.
Now he is telling to divide this to get the HCF, so that it will tally with this number.
Yeah, do it
So
now.
it will be 1 by 4 now.
1 by 4.
So it will be same, no, sir. This number and this number will be same, no, sir.
So that is what you, that's what
That is
you,
what he is
your
telling.
argument that is.
But I want to check for other numbers.
Other numbers are, then we have to
will
check.
get to know
2 by 3, 3 by
Yeah.
5, 5 by 10.
And you see now what is the next number? 2 by 3,
3 by 5,
3 by 5,
5 by 10.
5 by 10.
Now let's convert into natural numbers, sir.
Yes.
By taking LCM.
LCM is what?
LCM is
30. 30. It means 2 by 3
into 30.
into 30 for this one.
3 by 5.
3 by 5 into 30 and 5 by 10 into 30. This is 20, correct? 6, 3, 18, okay? 3 into 5, 15, yes.
Here HCF is 1.
Here SCF is, yes,
1.
1.
Right?
Here SCF is 1.
Now we multiplied LCM now, sir. Now divide the LCM.
So
1 by 30.
1 by
30.
30.
Then it is the HCF of
Where you checking that for one method?
SCF.
ಇದಲ್ಲ
ಮಾಡಲ್ಲ.
ಯಾವುದು?
ಓದ್ ವರ್ಷ ಕೊಟ್ಟಿದ್ದಾರೆ. HCF of numerator 2, 3, 5, 1.
Yes, sir, it will come.
1 by 30.
Then in
1 by 30 means what?
That is the
HCF.
HCF.
of given fraction.
For that also we got 1 by 30, no?
Yes, sir.
So this means
So
what?
this means conversion is universal. Now we come to conclude.
Yes. Okay, we'll try for one more number. So we can say this is as a property, one of the properties. Okay. So minds are working like that. You're right. Let us take another examples of it. Let us take one some fractions. Let us take like take 2 by 5 and 3 by 4. Let us take and 1 by 8 we can take. Okay, we can do 1 by 8. Now first we'll see convert into the natural numbers.
Yes,
And what will LCM of 5, 4, 8. 4, 8, 8 is LCM. 40 you can take LCM.
40
LCM is 40. 2 by 5 into 40, right? 3 by 4 into 40 and 1 by 8 into 40. Then what happens now? 5 8s are 16, this is, okay? 10 means 30, right? 5, this is the natural numbers.
Now HCF among 16, 35.
Actually what happens now? 1 only SCF. For SCF of given numbers is 1. Okay.
So for
1 by
40
1 by 40.
is the HCF of 2 by 5, 3
40. This is the SCF in other right, isn't it?
Yes, sir.
SCF of fractions if we take. And now we can see here what happens now.
HCF of numerator.
SCF of 2, 3, 1 by LCM of 5, 4, 8. Now we can take like this. What is SCF? This is the one only. Okay. LCM. Largest number is what? 8. 8 to 16,
40.
16, 24, 32, 40 only. Yes. So 1 by 40s. You are right. Wonderful.
In case if you forgot or confused between the formula, then we can go like this.
Yes.
If you ask in the question that HCF, find the HCF after converting to natural number, we can find
Yes, this is also one property. Okay. So good, wonderful. CSAT is working now. Okay. Now switch out brains are switched out to CSAT pattern now. Okay. Yes, wonderful. Even I have learned now only this. I have never checked it. This is wonderful. But I divided the numbers also. That is Wonderful. Yes, next. What is a exponents is over now, isn't it? Exponents are?
We should do.
Over. You are doing that question. We did exponents.
Exponents are over, that's all.
Over.
You have to take the list, that is. That's all. LCM will take the highest power, exponent. We will take here is a lowest thing, that is. Exponents is easy, that is actually. Right. So now we can take, I think all this LCM SCF is, business is done, that is. For example, see what happens now here, like you can question, puzzle type question may be converted here also. Even we used to play in our early childhood days. There are 3 cans. This is the can 1, okay. This is the can 2, can 3 this is. And see, this capacity is what, 3 liter. This is a 5 liter. And this is the 8 liter. What is a common measure is required? What is a common measure? Measure required to fill all the tanks, cans, that is.
HCF.
The SCF is required. One, that is the thing. I think maybe in 2021 the question had come, this is CSAT. We were playing in childhood days, this is. The common measure is required is what? 1 liter capacity. Highest common divider is required. So it's like that. So we don't need time at all, but subject to classes. People think that is, like I have done engineering, I have done science, I am a science graduate, maths graduate, I know, no, they are not, they are roaming in the roads. If I ask them, no, this time I did not give exam. They are like blatant lies they are telling. Whom you are telling lies? You are killing yourself. It's like that. And I know. No, you don't know. That is the thing. Anyway, so we can see that is 85% of the people are not qualified from this exam. That is the thing. That's why first they will filter CSAT paper first. After that only they will go for the paper 1. Paper 1 most of the people will do. They work hard, right, day, night and everything. Yes, this is the thing. Yes, shall we wrap up the program? We'll see tomorrow. Whatever the doubts you have, we'll make up tomorrow, that is. So thank you all.